Okay, so here we are, testing out this feature in the Microsoft Word here. I don't know if it's going to work exactly as I want. Usually I play these PowerPoint in a Zoom meeting, so we're going to see. Okay, at any rate, this is a rehearsal of a talk that I'm going to be giving at Marist University on November 14th. That's tomorrow in my time, so whenever you see it, I don't know, but I'll be heading up there to give this talk on testing the horror theory of phenomenal consciousness. How do we advance slides? Ew. And there I am down there. Okay, so that might not be the best place for me to be in some sense of that term. Okay, anyway, so a kind of familiar theme from my work, I guess I'd say, something I argue for all the time, is that the science of consciousness is currently at a crossroads. And by what I mean by that is that the science of consciousness is at the point where it's trying to establish itself as a viable area of the cognitive neurosciences, such that we could have a neuroscience of consciousness as a distinct subfield. And my kind of guiding idea here is the way that will happen to attention. And if you look at the history of this stuff, you can see people in philosophy talking about attention going all the way back to Descartes at least, probably earlier. Now I don't want to get distracted by talking about earlier, but it's at least in Descartes, and through Locke and Berkeley and all these guys. They're talking about some role for attention. By the time we get to William James, attention is something everyone knows but doesn't know what it is. And then now we come to our current time, and we have something called the dorsal attention networks, the dorsal frontal parietal view about attention. And we don't know every single thing about all of this stuff, but we have at least a kind of set of areas in the brain that we think are important for attention, and we have a way of testing them in a sort of experimental designs and a kind of general, my rule of thumb way of putting this is we know how to write the intro textbook, like a cognitive neuroscience textbook on attention, but we don't really know how to write the cognitive neuroscience introductory chapter on consciousness. So that's what we need, in my opinion. And in order to get to a point where we have something like that, I think we need to empirically test the theories of consciousness that are currently on offer. Now, theories of consciousness, in my view, are supposed to be theories of phenomenal consciousness. So there's many different ways you could use the word consciousness, and I'm not going to go through all of those. I have a whole separate talk where I try to distinguish the different senses of consciousness and how they relate to the phenomenal sense. But the basic idea is just that phenomenal consciousness involves that there's something that it's like from your point of view, some way that the world is presented to you subjectively. And in my view, the science of consciousness is got to try to account for that phenomenon. It's a real feature of the world, and we want a theory of it. And we currently have several kind of accounts for at least how this might relate. Did I not turn my email off before I started this? I wonder if that's going to... Okay, anyway, so my claim is that the central challenge of the cognitive sciences is to adjudicate between these big ideas that we have. So these are well-known candidates: global workspace theory, etc. Global workspace theory, IIT, being two that you hear about a lot, but there are several others as well. So we have the recursive processing theory of Victor Lama. We have attention schema theory from Michael Graziano. We have the horror theory, higher order representation of a representation. That's my version of the higher order theory. Then we have perceptual reality monitoring. That's Hawk-One's version of higher order theories. And obviously one thing is clear is that we love acronyms and making up combinations of letters. But these are, all jokes aside, theories in the cognitive neurosciences that people, to some degree or other, take seriously. And my view is that if we could figure out which of these was on the right track, or which ones we want to combine into some bigger picture, or which ones are on the wrong track, and how they relate to what's going on in the brain, then that would be a great step forward. Okay, great. So that's what I would like to be able to do. Now, the problem is that, unlike a lot of these other theories, when you're talking about higher order theories of consciousness, they're easy to misunderstand. And the primary reason for this is that they were developed by philosophers. Whereas, like global workspace theory and IIT are developed by scientists. So, whatever you think about those things, they sort of know how to test their theories. But many scientists are not exactly sure about how you're supposed to test this philosophical theory. And so I'm going to focus on higher order theories for the rest of the time for that reason. In particular, I'm going to talk about how we should formulate the theory in such a way that we could test it empirically. And so when I present my version of the higher order theory, I'm presenting it specifically in a way that focuses on how can you test it. And so there are many different varieties of these kinds of theories, and I'll mention some along the way, but I'm really going to focus on the version that I've developed because that's the version that's the experiments that I will be talking about are aimed at testing. So that's very fun. Now, what's the basic idea? I'm going to go through the details, but the basic idea is that the higher order theory of consciousness involves inner awareness, crucially as an element of phenomenal consciousness. That's the basic way of thinking about what a higher order theory is, on my view. Higher order theories are simply the ones that say that you need to have inner awareness in the explanation of phenomenal consciousness. Now, what is inner awareness? I'm aware that this term has a kind of history and that it can be used in many different ways, but I'm trying to invoke the folk psychological common sense idea that we have an awareness of the external environment, an outer awareness, and then also an awareness of our own mind, an inner awareness. And this idea, maybe traces back to Aristotle when he says things like, when you perceive, you also perceive that you perceive. That's a weird thing to say, maybe, or maybe it means you have a kind of awareness of your perception of the external world. Similarly, people like John Locke have said, consciousness is the perception of what passes in a person's own mind. And Immanuel Kant famously said, the I think must accompany or must be able to accompany all of my inner representations, or else there could be something in my mind which I could not be aware of or think. So whatever these guys are trying to say, contemporary philosophers have been inspired by these remarks to think of consciousness as involving inner awareness itself. And the horror theory kind of takes that idea and runs with it. So phenomenal consciousness, on my view, just is inner awareness. And inner awareness is a representation of your own mental life. So phenomenal consciousness just is a higher order representation of your lower order representations. It's the mental life that one has involves representing the world, and higher order awareness involves being aware of those representations, according to the horror view. Okay, so now I'm currently involved in two very different projects aimed at looking at various instances of the horror theory. And, that's always been a bit of a, I don't want to get distracted, and I probably won't be talking about this in my actual talk when I deliver this, but, the actual history of this stuff is a bit interesting because these projects are both funded by the Templeton World Charity Foundation and their adversarial collaborations, Accelerating Consciousness Research, ACR, which is largely associated through the work of Dawood Pot. I might edit this part out because I don't think I know his last name. I just know him as Dawood. Oh God. Anyway, so they have in these two projects here, each have roughly like $3 million to conduct these experiments that we got together as a group and thought about and proposed, and it was pretty rigorous. And I heard that some of these were very competitive, so I wasn't involved in evaluating any of that stuff, but I was involved in the meetings to try to generate these experiments. So one of them is led by B.U. He, Dave Chalmers, and Ned Block. And the set of theories there is the horror theory, higher representation of representations, and perceptual reality monitoring, that's Haquan, and recurrent processing theory, that's Victor Lama. And then the other group is led by Steve Fleming and Axel Clearmans. And there, it's just an infight between higher order theories. So we have the horror theory, PRM, and then we add Steve Fleming's view, the higher order state space view, and then I guess I don't know why I don't have Axel's view on this slide, but there's also his SOMA, his same order monitoring account. So these are different versions of higher order theories, and they differ in their like computational commitments in a sense. So that's very interesting. Now, it's to me having horror theory in here is a bit weird because all these other guys are serious people, and of course the reason that I'm here is because what they really wanted was to have like someone like David Rosenthal or Joe Ledoux, or anybody who is a kind of well-known defender of higher order theories commit to making some predictions, and it was too difficult to get these guys to commit. But the horror theory does make some pretty clear predictions. So I guess I was like 45th on the list or something like that. But they eventually got down to me, and I was like, yeah, let's do this because I've been saying we need to do these types of things since 2011. So I'm all for it. And I'm very excited to be a part of these projects, even though for whatever accidental reasons that may be. Okay, very cool. So my goal then is just to go through the specifics of the horror theory, since that's the theory that's being tested. And I won't really talk too much about other versions of higher order theories, but then sort of towards the end, I'll get to the experiments. And really there's like a bunch of experiments, and some of them are in various stages of being, just starting or almost done. So I'll focus on the first set of experiments from the first group, and wave my hands, and you can expect another set of talks or whatever coming later from these other ones. So that's very exciting. All right, so what is this horror theory of phenomenal consciousness? Well, remember, my goal is not really to convince you of it, because I sort of think that the only way you could become convinced of it is empirically. So my goal is to kind of just set it out and to draw out the predictions that it makes. And of course, I have a whole book on this called Consciousness as Representing One's Mind, if anyone wants to torture themselves by knowing about this. Okay, so I kind of, in my mind, start off by thinking that there are properties in the world. And here we have a generic property, let's call it R. And I'm going to suppose that R is the property of reflecting and absorbing light in a certain way, or something like that. Let's just say that it is. And I want to call such properties perceptible properties, because they're the sort of properties that we come into contact with in perception. The ones in the world, the worldly, physical things out there. Okay, now they're perceptible because there will be a mind eventually. So here, this red circle is a mind. And the mind will come to behave appropriately with respect to this property. And we might say, well, okay, there's some state in the mind of this perceiving organism. And maybe there's something like a concept in there, something like an attribution of a perceptible property to the environment, like there's red out there. Maybe there's something like a mental quality that doesn't involve a concept, that involves some other kind of way of keeping track of what's out there in the world. Maybe it's a mix of the two of them. Maybe it's just one, but not the other. So there's lots of things you could say here, but whatever you're going to say, there's going to be some mental state, which is the perception of red. And it's an awareness of the world out there, and therefore we call it the first order state. And I'm a representationalist about these sorts of things. So I think that this state represents the perceptible property R. Okay, so that we could say, what does that mean, and blah, blah, blah. But I think that this is the general picture about how it is that you become aware of things in the world. And this first order state, which I'm not really drawing all the lines here, but it would have lots of connections to other first order states and to behavior and to the world. And it would really largely account for how you respond to the world. Okay. And if you're a higher order theorist, then you say this system right here doesn't have phenomenal consciousness. In order to do that, it has to have this further higher order state. So to go from the state where you didn't experience to now there's red out there in the world, so that perceptible property is now like red as we consciously experience it, then the theory says there's got to be some higher order state representing you as seeing red, representing you as being in that first order state. So, on my way of thinking of things, this higher order state is going to have some kind of indexical or pointer element to it, which is going to pick out the first order perception. And then you're going to say, roughly in representational terms, that's me seeing red. I'm seeing red. And at that point, you become consciously aware of the perceptible property and you experience seeing red out there. And we go around saying that the perceptible property is this redness, when really the perceptible property is R. It's this reflecting thing, which causes the first order state and then produces the higher order state, which is the experience, which is the conscious phenomenological thing. So that's the horror view in a nutshell. There's a lot more details in that, but that's a large part of it, so that we end up with this picture that in order to have a conscious experience, you require this higher order state. Now, there's many other first order states lurking around in one's mind, and the horror theory says this indexical component, this indexical element that picks out the first order state, it is going to play a causal role in the mind of the organism, so that which state you point at is going to affect the internal functioning of the mind and the behavior of the organism. So that if for some reason you got hit on the head and this indexical component, or for whatever reason, picked out this green state instead of the red state, but it had no effect on the higher order state, then the horror theory says, well, you would still consciously experience red. But since the pointer is pointing at the first order green state, then that state is the one that gets the boost from the pointer. It gets put into working memory. It gets further processing, etc. And so your behavior might change. You might press a button saying that you saw something which was green, even though out loud you say that you saw something red or something like that. You consciously see red while acting as though you see green. So the horror theory says that the indexical component plays a role, but it doesn't play a role in what it's like for you. But what is this indexical component, and how are these two elements related? Well, in my mind, actually, I have a different kind of picture. I don't think there's any arrows in the brain, any pointers. Instead, I have a kind of analogy on the way HTML works, or computer science. And the basic thing which occurs there is that you have some files in a physical location that's labeled with addresses. And then if you want to link to them, you list the address and give some instructions about how to access the file. So now I don't think the brain uses HTML, but I do think that we have something like analogously a system like this in the brain. So here I have now replaced the arrow with this grid, A, B, C, D going on the left and 1, 2, 3, 4, 5 going across the top. And this is sort of my way of thinking about, maybe how the visual system divides up the sensory cortices. And now we have states down there that you could list, so R star is now occurring in C3 and the conceptual component is occurring in A5. So they may be in different components. But now we have a higher order representation, which says the entity, whatever it is, which is in those states at this address, A5 and C3, is the one that's seeing red. Okay, so that's really how I think about what's going on at this level. And at that point, then, if you changed the conceptual component, then you would change the experience. So it says those states at A5 and C3 are me seeing cherry red. And of course, I used the entity before because I really do think it's kind of just a generic, like there's something which is in those states, and that's the kind of self component. So it's not a heavy duty sense of I, as far as I'm concerned. It's just this kind of, there's something in those states pointing down there, and that's the guy who's seeing red. That's the thing that's seeing red. Okay, something like that. Now, if it changes to scarlet, then that's going to change again. So what it's like for you depends on how this higher order state represents those first order states. Those first order states could be gone, and that representation would still do the work it does. Now, of course, the indexical component, which is saying those states which are located at this address, is now telling you to go and the instructions for how to access those states go tell you to go to that address and get what's there, then you do that. There's nothing there. So you're not going to be pressing the buttons or behaving in the right way because those states don't exist. But you're going to be saying you see the conscious color experience. All right. So that's basically how I think of things. And just to hammer this point home, even if it was like saying you see green, right? So it's like however it represents you, that's what you experience phenomenologically. Whichever address gets located, that's what state in the first order grid is picked out and therefore comes to have a different causal profile. All right, so there's some pretty clear predictions just at the high level that come from this way of thinking about things. The first obvious prediction is that phenomenal consciousness determined solely by the horror. So you find that and whatever that does, wherever that is in the brain, and you found the neural correlates of consciousness according to horror theory. So wherever the neural correlates of the higher order representation are, that is the neural correlates of consciousness. There can be mismatches between consciousness and the mental life of the organism because if you vary the first order states but keep the higher order state the same, then behavior will be affected, but consciousness will not be. What it's like for you will not be affected. But if you vary the higher order content but not the first order content, what it's like for you will vary, but your mental life and how you behave will stay the same. That's a pretty glaring prediction that you should be able to find cases where they mismatch in this way. And then furthermore, there's a prediction that there's some element of the higher order state which itself can vary without affecting consciousness. And that's the pointer content. And this is what's going to distinguish horror theories from theories like PRM and Haas, which say, no, the pointer is what's lighting up the first order states. Okay, so that's very cool. Now, the problem is that while it may seem like there's a straightforward way to map these ideas onto the brain, there aren't. And these are psychological level concepts that we've been dealing with: awareness, inner awareness, outer awareness, representation, etc. And we need to know how they're implemented in the neural functioning in order to go any further. But contrary to popular opinion, there is no principled link between neural anatomy and inner awareness. There is this kind of intuitive idea that there's a hierarchical structure in the brain, so therefore maybe there's this hierarchical way, also a hierarchical representational structure, so maybe they map on them that way. And so that you, by the way, this image on the left is just from Wikipedia. It's nothing too exciting. And the image on the right is my version of horror theory, sort of in the more schematic version. And many people think, oh, well, can you just map these things on directly like that? Like maybe the higher order states are in the dorsal lateral prefrontal cortex, and first order states are maybe in the occipital lobe, like, V4 or somewhere in that area like that. It is a pretty straightforward mapping. And there is some reason to think maybe, this is not the worst idea in the universe, but it's not entailed by the higher order theory that this has to be the case. And yet many people write as though higher order theories just are prefrontal theories, like the prefrontal theories and higher order theories. But no, it's that there's a specific implementation of the theory which says, well, metacognition is in the prefrontal cortex, and these kind of inner awareness states are like metacognitive in a way, so maybe they'll be there. But there's a different version of it that says, no, maybe it's not the dorsal lateral, maybe it's dorsal medial, and we still get these representational states. Or maybe, in fact, it's not even in the prefrontal cortex at all. Maybe it's in the parietal cortex, in areas more traditionally associated with self-consciousness. Is inner awareness a kind of self-consciousness? Well, metacognition doesn't really sound like self-consciousness. But inner awareness of me seeing red, sort of does sound like self-consciousness. So maybe these areas would be involved. And some people have thought that was the case. So I'm not saying that I think that. I'm saying that it's reasonable for a higher order theorist to expect to find these states in maybe the parietal cortex as opposed to the prefrontal cortex. Another kind of reasonable idea, and one that I've explored with Joe Ledoux and in other work with Hawkwan Lau, is that maybe it's not just one area of the prefrontal cortex that's largely associated with these things, but the whole network in a way. Maybe you kind of have a distributed network, a frontal parietal network. Maybe the self component is more in the parietal areas, and the that is seeing red part is more in the prefrontal area. Some of it dorsolateral, some of it more towards the medial area, some of it in the frontal pole. Maybe it's looping areas between these things. So this is a different way of thinking about how this higher order state might be implemented in the brain that I think is pretty reasonable, and would be the one that I would largely find most commonsensical if you really wanted to locate this in the frontal parietal region. And so, that's very cool. And you can make some empirical predictions, but not from the horror theory, but from this kind of way of implementing it. That's the kind of crucial point that I want to make. Now, you might say, well, okay, are we safe? Because, at least with the first order state, we can not play these kind of games. But even there is kind of unclear. Because while, for example, Victor Lama has a view that the first order state is going to be in the visual cortices produced by recurrent activity at around 200 milliseconds, so somewhere between that range, depending on who you talk to. Other people say, no, it's got to be globally broadcast. Now, of course, these guys think they're debating consciousness. But if you're a higher order theorist, then it looks like what they're debating is just like, what is the first order state? So which state is it which we re-represent or become aware of? And the Lama kind of RPT view says it's this early state occurring around 250 milliseconds, whereas global workspace theory says, no, it's this late state, maybe later, around 400 milliseconds. There's also the global playground, which says, no, it could be in between various places. So that's very cool. But each of these kind of views is, from my point of view, talking about what the first order state is. And so, that would be the state which we re-represent. And IIT, then, on this way of thinking, is also doing that and giving a separate account. No, the first order states are the integrated states, informationally integrated. So in that case, it's looking like, well, what even is the first order state is up for grabs, because it really depends on like how you think about what the brain is doing, and you can really kind of drive that home in various ways. But I think we've done enough to kind of make the point that there's no real horror theory at the neural level. There's different implementations of it, and the empirical record is compatible with many ideas, and I'm open to those. But in other papers that I've written, I've explored the role that the prefrontal cortex plays. But I am open to the idea that maybe it's the whole cortex that's somehow implementing these higher representations. It might even be recurrent activity. In my estimation, I think it's a bit humorous that Lama, that Victor is basically saying that consciousness requires recurrent activity, but then also is sort of saying, but I don't know why or what it's doing, this recurrent activity. And so that just highlights in my mind that we need a psychological level theory in order to make sense of what the brain is doing. And that recurrent activity, which is going from the fusiform face area back to V4, for example, might be a higher order representation. There's no reason as of yet not to think such things. So I'm not saying that I think such things. I'm saying it's really early days. And so my own view is that, yeah, it's reasonable to explore the prefrontal cortex. But if we sort of rule that out conclusively, it wouldn't falsify the horror theory as an approach to consciousness. It would limit our account of what implementations we might expect. And maybe if we eliminated all possible implementations, then we'd be like, okay, fine, this theory's out of here. But that's the way we'd have to proceed. So even finding no evidence for this view would be important, I think. Okay, so now finally we can get to these so-called empirical tests. So there really are two different projects. The one that's led by BU, Ned, and Dave, and the one that's led by Axel and Steve. So on the BU, Ned, and Dave side, there's also Jan Brasket, but I think maybe his side of the experiment might, anyway, it doesn't matter. So the first one is involving subjective inflation, and that's really what I'm going to focus on in the remaining time to a large extent, but to whatever extent I'm able to. The second experiment, change blindness. The other side of it has some very cool experiments, and I'm not really going to be able to talk about them, but I would love to talk about how these guys and what we're doing with adaptation effects, trying to separate imagination from perception, and even using hypnosis. So there's some very cool stuff happening. But I'm really going to focus on this one first. Subjective inflation is really an important empirical discovery, which I do think is going to help us advance this debate. And then we also have change blindness, which has been a historically very active area of philosophers trying to find evidence against higher order theories. So it's cool to see this still continuing. Okay, so now then, getting down to the details, this experiment 1, as it's known in the higher order versus first order adversarial collaboration, is really looking at these three theories, recurrent processing theory, perceptual reality monitoring, and the horror theory. Okay, and it's really looking at a prediction that, as far as I'm concerned, comes right out of the way the horror theory was set up, which is that you expect there to be these mismatches between the first order and the higher order states. And in the perfect case, you expect there to be like a complete mismatch where there's no first order state and just a higher order state. But in the more ordinary garden variety cases, you expect there to be the higher order state saying, I'm seeing red, when the first order state says you're seeing scarlet. So it's more vague, and vice versa. And then when I met Haquan, he came to New York in 2010 or something like that to give a talk and to come to Columbia. It was 2009. It doesn't matter. Who cares? And he gave a talk at the Grad Center, and we started chatting about all of this stuff. And it turns out that his lab had produced something which looks like a verification of this prediction. So that's the way I was thinking about it. That's the way he was presenting it. And we got together and started writing The Emperor's New Phenomenology paper. This was around 2010 or so. And that paper annoyingly didn't get published until 2019, taking all the wind out of our sails. But still, it was cool that at the time we thought, okay, so there's this prediction that the theory makes that you would expect to find the first order states not changing, the higher order states changing, and that correlating with a change in experience. So there would be more in the experience than the first order states could account for. Okay. And we thought subjective inflation was an example of that, because in subjective inflation, you're able to show that people are equally good at discriminating between a stimulus in their unattended periphery, saying it's there or it's not there or whatever. And they're equally good, but in the unattended periphery, they judge it to be there, brighter, visible, more so than in their attended region. Interesting. And then there's a debate about, well, what really does that show? But surprisingly, no one really has ever drilled down on the details of subjective inflation and say, okay, so what are its boundaries? How widespread is it? There's some conflicting evidence in the beginning. So the first stage was just to do a behavioral investigation to see whether there is subjective inflation. I'll kind of go through the details of that. And in my opinion, it's done. There is. And there's a paper that's in current, review, submission, something. And then there's a second stage where they're looking at the fMRI activity to see whether it bears out what we're saying. So the higher order theorists, that is to say. All right, so let's go ahead. This is the paper that I was saying. So attention robustly disassociates subjective objective performance and subjective visibility reports. So this is all the hard work's been done by Megan and Rachel setting up all this stuff, and then the real hard work's been done by Karen, Brian, and Michael, Angela, and all of these other persons in between here. Some of whom I don't even know personally, and then there's some slackers in the middle here. There's myself, Victor, Hakwan, and then ultimate slackers down here, Ned and Dave. And Jan and Bu are not slackers either. Anyway, okay, it doesn't matter. There's a lot of people working on this project. I played a small part in this, just providing feedback on the experimental design, suggesting, yeah, I would say this or would not say that. So if it were up to me, I wouldn't even have my name on this paper because I feel like I have minimal contribution to it. But I did make some minimal contribution to it, so I guess it's okay if I'm in the middle there somewhere with everyone else. Okay, very cool. So that paper, they've presented it a couple times, and I hope it's going to be published at some point. I don't know the timeline though. So this is from a preprint, and this is kind of a very simplified version of the experimental design. It's actually a lot more complicated than this, believe it or not. But I'm going to kind of use the remaining time to go through the simplified version of it. My little circle thing here is going to be annoyingly in the way. I wish I could be on the left-hand side, but believe it or not, I could not figure out how to do that. Anyway, okay, so what we're looking at is kind of the timeline of experiment 1, the behavioral side of it. So you're laying there, sitting there in the fMRI. I guess you'll be laying there, or I actually don't know. And you're looking at the screen, and you fixate for a set amount of time, 650 milliseconds. And then they give you a pre-cue. And the cue could either be neutral, which is that it doesn't tell you anything, or it could tell you to kind of attend to one of these 4 corners. So here, this is telling you to the right, and over on there is telling you to the left. And then you're going to get one of 2 tasks. So you're either going to get the task of detecting something, or the task of discriminating something. So is there something there, or what is it? Tilted in a certain way or whatever. And then you get a response, and this cue is pointing over to the right quadrant, and then you would have to report what was there. And then they might also ask you about the unattended. Okay, so that's the timeline. Now, what are they presenting? Well, there's 4 experiments they're doing in this overarching experiment 1. And in experiments 1 and 2, they're using these gratings. And in experiments 3 and 4, they're using these figure-defined ovals. Okay, so in each case, they have one experiment where they do this thing at threshold level. So they check for each participant. When can they sort of get it wrong half the time? And then the other experiments, they're just doing it in full on plain sight, not at threshold. So, and then they're modulating the clarity here, the contrast, and over here the length of the line, making the figures more visible, making this more visible. Okay, and the reason why they chose these particular stimuli and so forth is because the Llama Lab has used things like this, and they're pretty standard. Okay, cool. So that's what you're presenting. Very cool. And at the same time, you're getting objective and subjective reports. So this is all one long figure, but I broke it in half to fit it on the screen. You can see where it says objective orientation report. Okay, so that's where this would be one long thing. So you're getting the objective orientation report. In the one experiment, it's whether the thing is tilted left or tilted right. In the other experiment, it's whether the oval is horizontal or vertical. But you're also getting the subjective visibility reports because you're asking whether they saw the stimulus, whether they saw just the stimulus or also saw the feature, like what it was, or whether they didn't see it at all. So you're getting their objective, like their ability to determine whether it's there or not in one experiment, and whether it's tilted or not in another experiment, and then also asking them, did you see it? So you're getting both. and also having them compare it to a reference. So over here on the response side, it says when you saw it, is it stronger than the reference one? Is it more visible than this, or is it weaker than this? And then finally, did you see the tilt? And then down here, did you see the feature? Did you see the stimulus? Same thing, and then stronger than the reference, right? So they're presenting these things, getting a lot of data. And the basic key thing that bears on subjective inflation is whether subjective reports are higher for unattended items when they're still matched for performance to attended ones. So when you're just as good between the two conditions as saying it's there, it's not there, it's tilted, it's not tilted, are you saying that it's more visible, that it's you can see it clearer, etc.? All right, so that's the basic idea. Now, there's a very interesting approach that they take in this paper. They do a lot of interesting math, and Brian Maniscalco is involved in a lot of these interesting ideas. So I'm not going to, we're running out of time, and anyone interested, they could ask me to ask them for you, because really a lot of this is very technical. But they calculate this thing called the AMI, which is the Attention Modulation Index, which is the AMI for the AUC, which is the area under the curve, which is this way of trying to get at what the difference is, taking all the conditions and collapsing them into one. So in the threshold condition and the super threshold condition, if you just look at the cases where they're matched in their performance, is there a difference in the stimulus visibility or the feature visibility? And if the answer is, if the number here is positive, then the answer was yes, there is a difference in that condition. And if the answer is negative, then the answer was, yeah, there's a difference in the other direction. And if there's no difference, you get 0. Okay, so it's a cool and clever idea. And it allows you to see sort of right off the bat that there is indeed this disassociation in these 4 conditions, or at least in some of them. So just taking this very quickly, in the threshold condition of the contrast-defined gratings, which is this first thing on the left, we have light green indicating the stimulus visibility judgments, and the dark green indicating the feature visibility judgment. Okay? And threshold means that they're 50% of the time they don't see nothing, and 50% of the time they do see some. Okay, and in those cases, when they are matched, when they're equally good at saying what's there, what's not there, what's tilted, what's not tilted, etc., nonetheless, there's this greater tendency to say they saw something and it was more visible. That's the stimulus visibility judgment, and also that they saw the tilt and that it was, but they're not better in the unattended region, right? So this is robust replication of subjective inflation in the threshold condition. And surprisingly, though, you also get it in the supra threshold condition, which means that it's clearly visible. Like, they're not messing around with like it at being just at threshold. It's just there. And yet when they're attending here but making a judgment about over there, they rate it as the stimulus is more visible and the feature as less visible. But either way, you get this disassociation between what the subject is saying they experience and their objective performance. And the same is true for these texture-defined figure ground ovals. At threshold, you get subjective inflation, and even at super threshold, you get it, but only for stimulus visibility, not for the feature visibility. It's 0. So that's interesting. But this is really cool finding that suggests that subjective inflation is real phenomenon, not just a byproduct of Hawkwon Lab first foray into this. It's not just a feature of messing with the stimulus to make sure that they're matched between the two conditions. It does look like a robust feature, which therefore could possibly account for why it is we think there's more phenomenologically manifest in our experience than we have reason to believe. Okay. So there is subjective inflation, but that doesn't automatically suggest that the horror theory wins here, because you could have a first order explanation of this. So, for example, one first order explanation is that, well, if this is really a phenomenological feature, if there really is a difference in the experience of the person, then there should be some difference in the first order representational states. They should like get more robust as well and less robust and so forth. So that if you're someone like Hakuan Lao, who thinks that perceptual reality monitoring is just the indexical component, but the experience is the first order state sort of lighting up after it's being pointed to, then subjective inflation phenomenologically the pointer should inflate the first order representations. You should see it sort of become stronger in the signal. Whereas the horror theory says, no, the inflation should occur at the higher order level and not at the first order level. So you would see a difference in the higher order activity, but not in the first order activity. Whereas Victor Lama says, well, I don't know if this is even a phenomenological thing. This seems like it might be some product of a judgment. So you wouldn't see any change in the first order recurrency signals. You would see a change at those other levels. You would see the first order recurrency activity being the same, because your experience isn't changing, but your judgment about your experience is changing, and that would be in the higher order areas. So we kind of have a clear prediction then about what's going on here, and since we now sort of know that inflation is a robust phenomenon, then that means, okay, we're now on the hook to see what does the first order theory say about it. And if it's phenomenological, which I would say we have now evidence for, that this is a phenomenological feature because it's very robust. It doesn't look just like a judgment about something, but this is something you could debate about. So if it is a phenomenological feature, then we would expect the signal at the first order level to change. And if it doesn't, then that looks like it puts some pressure on that view, assuming this is phenomenological. It either forces it to say it isn't when it likely is, or you're going to have to say, well, the first order state must be somewhere else or something of that nature. Either way, you're going to have to adjust your theory. So that would be progress. Okay, so at that point, I guess I would say those are the conclusions and end it. Thank you very much. I'm over time, but in real life, I guess I have 50 minutes, what they said. So up to 50 minutes. So I guess I'm sort of on time, even though I have a lot more slides to go.